have an email list. Most of you probably are already on it, so I'll just go right past that. Other places to get info on meetings would be Facebook or our chapter website. I update that. And actually, the website has the next 2 meetings listed for registration. As most of you know, every meeting you attend in person, if you're an SBE member, you get registered or signed up for a drawing in November for our holiday party, and the chapter will pay for an SBE Members Plus membership for you. Who won it last year? Eric Hood won it for last year, so we just paid for him to. We actually just give you the money, and we just trust you'll use it for your membership. What else? The SBE membership drive ends May 31st, not March 31st, like I put on the paper. Recruit new members, have them put your name down as the referral, and at the probably June 1st or something, the National will do some drawings. They have some pretty awesome prizes, SBE Cert Preview, a free webinar registration, $25 gift certificates for the store. The big prize is the grand prize is a trip to the national meeting.
Which I won a few years ago.
Yeah, so if he can win it, anybody can win it.
Right.
Our next 2 meetings, next month, June 18th, it's going to be at the NIST facility. I don't know if it's NIST or NIST. Fred, do you know? You should know. You should know. You're the one who brought it up to me. But it'll be in Boulder. So, you need to register pretty early for that because they need some specific info, DNA checks and stuff to make sure you're not a terrorist.
Fred's out.
Yeah, Fred can't go. And then finally, July 18th, Friday, that's a Friday lunch, will be our picnic, our annual picnic at Lookout Mountain. So that'll be fun. Famous Dave's. We got some great prizes to give away, Pro Audio and BW. What was BW Warehouse? BSW. There's too many B's. BGS, B. So yeah, that BSW. I think it's BSW.
Yeah.
Have provided us some microphones and other items. Register for that. We are charging $20 per person to help offset the cost of the food and other items. So sorry to you online, you won't be able to attend those meetings unless you fly to Denver. And with that,
But you're invited.
yeah, you're invited, but you have to pay for it yourself because my dad won't. And then finally, on the back of the page, for those of you here, just a list of our sustaining members. These are our companies that have donated money to us to help us get food for some of the meetings that people like Jeff aren't providing, as well as just other, things. We have to pay for the website somehow. So just keep them in mind when you need to purchase items, and it's on the website for those of you online. And Jeff, thank you for lunch if it ever gets here, and I'll let you have it.
Wouldn't be the first time. So I'm going to say right off, like, look at everybody here and the folks online. I think almost everybody in this room could teach this better than I can, which makes it more fun.
Here's why.
Well, and here's why. Anybody in this room under 50 other than Amanda? Amanda doesn't count. Yes, they're going to say, I was it once. I'm 50 with several years of experience. Yeah. The reason I mentioned that, I've been doing this for 35 years. I know of at least half a dozen engineers that have been found at a transmitter site dead. Every single one of them was our age, not younger. Because the young people are careful about stuff. We've been doing it for so long, you start working by muscle memory and stop paying attention to safety. This is a week-old knife cut, goes halfway through my fingernail because my knives are sharp. Because I've been deboning chickens forever, since I could barely, pluck a chicken. And I'm just hacking and slashing and doing my thing. And the next thing I know, it's like, there's not supposed to be that much blood. So yeah, you get casual about it, right? You get doing this stuff so long. I mean, you work on the same transmitter over and over and over, and it gets easy. And that's the scary part, because then you get complacent and then you did. Out of the 3 engineers I know that have been electrocuted on the job, 2 of them were working on boxes that they've been maintaining for over 2 decades. They knew those transmitters inside, outside, upside down, and backwards, and they ended up just as dead. So this is kind of the refresher course. Amanda said RF101, and I said, scare the pants off everybody. Because that's the problem. I told somebody, I said, you don't need to be afraid of the transmitter, but you do need to understand that the transmitter does not give a shit if you go home or not. Transmitter doesn't care. So you're getting the what do they call it? The uncensored version today, apparently. So we'll talk about the parts. The what? Yeah, that's it. After dark rated. So we'll talk about the pieces and all the acronyms, but most of this we're just going to fly through, and y'all can throw in your 2 cents worth anywhere you want. And I mean, I'm going to pick on Fred mercilessly just because I can. We work together, and because he knows more than me about a lot of things. I might know more than him about 1 or 2 things, but it works out. And this is the thing to remember. Everything that we do in this job, except for the paperwork, and Lord knows there's enough of that, everything comes down to volts, ohms, and amps, even the IT stuff. Even if you're dealing with fiber at one end or the other, there's still volts, ohms, and amps. And so that's the kind of thing that we need to focus on, because you'll get so used to, you ever walk up to a transmitter that you've seen a million times, you see a light and you go, oh yeah, I know what that is. And 4 days later, you're still trying to figure out what it really was. You get, like I said, you get complacent. So start paying attention to this, the Ohm's law. We gave out a whole pile of Ohm's law wheels. Are they making fun of me online already? Oh, perfect. That's good. So it'll be awesome when we get to the walls of text then. But yeah, so everything we do is Ohm's law, one way or another. Either volts stopped going through something, or a lot of volts came in and blew a bunch of stuff up, or current stopped flowing. You know, so typically, if you've got the same voltage and you don't have any current, your resistance has gone way up. So your bleeder resistor is fried, or whatever. And every single transmitter on the planet, don't care whether it's AM, FM, TV, shortwave, ham radio stuff, 5 blocks. That's it. Bite-sized pieces. Break it down. With the younger folks, they tend to get so intimidated because you get this big old 14-foot wide box that's 6 feet high and 4 feet deep and makes a noise like a bunch of angry bees. Still the same 5 pieces. I should say, and I didn't mean to point at Amanda when I said that directly. Honestly, I didn't. It's getting back for that old people joke from earlier. But the first time I met Amanda, she was in a stroller, and it was at the KLTT site. It was right after you guys bought that. Remember we came up? So that was more. Really? No. I'm let down now. But that was more than a year or 3 ago. So here's the question. I mean, I asked this question to everybody here. I think I already know the answer. How many people have been working on transmitters most of their career? Fred, put your hand up. I already know you've been. How many people came in from the IT world and learned transmitters kicking and screaming? Yeah, see, so y'all are my IT security target demo. But yeah, this is the kind of stuff that it's just second nature. You just stop thinking about it after a while. They all use the same pieces, and whether it's a tube or solid state, it's just a make a little signal bigger device. You know, I mean, if you look at a tetrode and look at a MOSFET, schematically they're almost identical. You know, mechanically and electrically, not so much, but they work a lot alike. How do you make AM? Little signal bigger, but you put your audio on top of it. So how far you adjust the audio is your amplitude, audio amplitude. How fast you adjust the audio, that's your audio frequency. Pretty straightforward. With with PDM, you just use a reference signal, which is our audio, for a Class D amplifier. Almost everybody's using some variation of this now. I mean, a lot of it these days, like on our NX boxes, that's all done in one chip on a computer. So we just generate a signal, we program an algorithm and say, if you give it this audio and tell it this frequency, this is what you should create. The cool thing is that it all comes back to the same. Anybody remember deriving complex waveforms in college? Didn't do that? Anybody ever? What's that? Fair enough. Fair enough. I mean, Fourier analysis was one of the biggest parts of our tech school program, and I could probably figure out how to do it with Google. I could, but try to pull it out of my head. But that's all we're doing these days is if you tell a system what you want, it will tell you what you need to produce it, or vice versa. You tell it what you got, and it'll tell you what you're getting. The cool thing about that, because it's almost a software-defined transmitter, the cool thing about it is that now you can theoretically broadcast a signal on 89.9 and 107.9 out of the same amplifier, because you can create it all in one computer. It doesn't need multiple exciters. You just have different audio sources going in. The challenge becomes, and we have played with this just a little, challenge becomes the intermod products. The linearity you need to minimize the intermod means that your efficiency goes down to less than TV. You know, I mean, on an FM box, and we've done this to prove it. I can take a 300-watt transmitter and I can put out a signal on 88 and 108 simultaneously, independently modulated, at about 10% efficiency. So I can get about 5 watts out of that 300-watt transmitter, which makes it kind of not cost effective at the moment. But it's cool idea. And again, it's all math. So they say engineering's just math, but louder. So if you look at an AM transmitter, again, same blocks. Oh, right, it's a television. I can't use, this was supposed to, I bought this because they said it'll work on TVs. No. Anyway, so same deal. Exciter, amplifier, filter, power supply. What I don't show is the control stage. Every 5 blocks. Obvious stuff to remember. You can go over. There are certain brands of transmitters that do not like negative clipping, negative modulation on AM. I'm not mentioning any names, but they don't have my company's logo on them. That's all I'm going to say about that. Explosively, yeah. If by shut down you mean blow a bunch of FETs, then absolutely that's what they do. And I say negative modulation, MDCL at negative modulation. So when you're varying carrier and amplitude or audio at the same time, bad things can happen. Some of them didn't like the minus 100% modulation on an AM stereo generator. So then again, it varies from one to another, but it's something to be aware of. And here's the thing, every transmitter, and I don't care whose logo's on the front of it, every transmitter has its own little quirks. Some are features. Some are just the way they were put together, but every transmitter has its own way of reacting when you do stuff to it. BC1 with Crystal Gale. Don't it make my brown eyes blue? Thump, click. You know, I mean, it doesn't matter what transmitter, everyone's got its own little. We discovered on our ND series that Michael Jackson's Beat It at 150% modulation would cause the transformer windings to arc against the floor of the transmitter because there was so much current, it magnetized the copper windings. So That's pretty awesome when you're in a dark room and see a sheet of green flame shooting out the bottom of your transmitter. You know, it's like came with its own light effects. Pretty cool. FM, just like AM, except now we're making the signal faster and slower instead of bigger and smaller. It's all just the carrier. I mean, the audio is just how we modulate that carrier, how we change it. But the carrier is the carrier regardless. Other thing to remember, here's troubleshooting tip number 1 when the program director calls you on your AM and says, we're off the air. Do you hear silence or static? Is off the air or you host your automation system, 2 totally different topics. Always, we have a sign in customer service that has been there since I did support work 20 years ago. And it's a picture of an AM tower with kudzu growing up about 20 feet up the tower, just vine. And the call we got was every morning when they went from pre-sunrise to day power, the transmitter shut down with SWR trips. And the first thing I said was, almost got to be an antenna problem. Something's arcing. Not the antenna. We checked the antenna several times. It's not the antenna. And after an hour or 2, everything's fine. It starts working. If it was the antenna, it wouldn't do that. So, okay, well, we start checking power probe. We start tearing transmitter apart over the phone. 2 days later, he stops calling me. So, okay, I guess he solved it. In customer service, that's how you know somebody fixed a problem. They stop calling you. You never get the feedback unless you hunt it. So about 2-3 weeks later, because this predates email, I get a letter in the mail. 2 Polaroids, nice little letter. One showing the tower with 10 feet of vines growing up it, and another showing everything after Roundup had been judiciously applied and everything was defoliated. And he said, yeah, it was the tower. Dew on the vines was causing it to trip. As soon as the sun came out enough to dry the dew, everything was happy. Life was grand. Don't overlook the obvious stuff. And FM, same bite-sized pieces, everything. Like I said, I don't care what kind of transmitter. Okay, the way we make FM is a little more complex, but not that much. You know, I mean, you're still varying a carrier. And the amplifiers get a little more complicated just in current MOSFET days. But not that much. Again, almost everybody's using a variation of that. That's the older with the 1516. That goes back to the FM series. But now we're all using the same LD-MOS stuff, so doesn't matter much. The bigger challenge is LD-MOS if you're running HD. HD carriers require some level of linearity in the amplifier. Class D amplifier is very much nonlinear. It's on or it's off. MOSFETs are designed to be switches, on or off. So to make a MOSFET run linear requires some pretty careful biasing. And if you get that biasing off, your efficiency will go to pieces. Your shoulders, the digital intermod, what's the fancy word? Spectral regrowth. It's still it's intermod. But all it is the digital carriers and the analog carriers creating intermod products. But those shoulders will start to go higher. So that can be caused by a bunch of things. Could be caused by icing on the antenna. Could be caused by, in my case at my site, tower climber stepped on an antenna bay, bent it out of alignment. So the cool thing is now I can watch my modulation on my power meter. Not really supposed to see that on an FM transmitter, but there we are. We have a new antenna. It's a power company lease, so we've got to use a power company climber, which means that we've got to raise $5,000 and wait 5 years for the climber to be free. Right, yeah, it's incidental, all right. Well, on a 1400 watt signal, we get about 35 watts of varying reflected. Okay, again, with the current amplifiers, you see that not a huge pile of difference. I mean, it's amplifiers and amplifier. Current goes in, or little signal goes in, big signal comes out. Little, yeah. Yeah, yeah. On the PA volts, 1, big honking line of filtering. Like I said, the linearity has got to be so much that any AM noise, and here's the other thing to remember with FM, AM noise is almost always power supply generated. Well, you got synchronous and asynchronous. The one we worry about is almost always power supply generated. So when your caps start to go soft, then your AM noise will go up. When your AM noise goes up, your multipath will go up too, typically. So if you start seeing multipath in areas where you didn't see multipath, start looking at power supplies and exciters, stuff like that.
That's asynchronous.
Thank you. Yeah, I can never remember which sync it is, async or synchronous, but you're right. Thank you. Yes, it is. Just like processor and processor. Sorry about that. So my one political comment is that y'all don't want us the 51st state because you'll have 41 million pissed off people that all show up to vote. So it would be the shortest experiment ever, but. And we're an expensive habit. So what do you worry about with FM? Oh, look, AM noise. And the other thing about AM noise is in addition to the multipath, it does impact your coverage area. That's probably the biggest impact on coverage for AM or for FM signals. Terrain. You know, you put a big hill here, it makes it a challenge to get to the other side of the big hill. Oh, look, here we go. I should read my own presentations a little more. I would already known that. But yeah, the AM noise is the one that we absolutely can control. And it is the one that is almost always power supply filtering, one way or the other. Almost always. Some of it's just crap design. So if you get that transmitter from China on eBay that promised to be FCC compliant, but didn't have any stickers on it to indicate that it was, that may be the first thing you look at. So the cool thing about FM, because this is where we get into wavelength, and again, that whole E equals I times R, 2FC and all that great stuff. A piece of wire can be an inductor or a capacitor, depending on how you lay out. TV, same way. That leads to some challenges because I'll give you an example. I had a customer send in an exciter board. The exciter board, like I said, in our boxes, it's mostly a big computer. We will not repair one if it's got burnt track on it. We will not rebuild a track because we're changing the tuning of that circuit. And that means that we've lost control over our signal. So that's one example. Now, if you all want to repair the track, that's totally up to you. And if it comes out good and Bob's your uncle, life is grand. But yeah. Oh, I did mention AM noise can also be impacted by tube quality. I don't have a lot of experience with glow FETs. So, you know, in my world, if a FET's glowing, that's typically a bad thing. But yeah, something else to pay attention to. This one right here, so all of our boxes have the spectrum analyzer now, all the FM boxes. And I use the baseband more than the spectrum part because the spectrum part is cool at looking at the carrier close in, but it won't go out far enough to show me any spurs or any harmonics. Baseband, I can tell you in a heartbeat if I got my left and right, my pilot, my left minus right, I can see my RDS. If I'm running subcarriers, reading services or whatever, they'll be on there. It's just an at a glance is everything the way it should be. So just a cool feature. Whoa, that's a lot of words. However, I'm going to touch on one thing about RBDS. David Layer spent 2 years driving around the country, monitoring stations in every market he visited on various rental cars, various different receivers, and taking notes on how they were implementing dashboard presence with RDS. And after 2 years of preaching it, he got disillusioned because broadcasters don't change. 30% broadcasters are doing RDS poor, right.
He did a presentation here.
Yeah,
It was very.
about the same topic. Yeah.
Told us what to do.
Uh-huh. And that's cool. The problem is, and I tell people this, the biggest problem about preaching any improvement in technology or the implementation of it is y'all are the exact wrong audience because you're already interested in education. So you're here and learning and doing anyway. It's the people that aren't here we need to figure out how to beat it into their heads. In my market, we've got 15 radio stations that I can pick up from my house, and I do have an RDS presentation in there. Out of those 15, 3 of them are not doing RDS at all, not even a call sign. 5 of them are duplicating the PS and the radio text so that you get artist and song titles scrolling by 8 characters at a time on the PS field.
See, that's what David recommended.
You recommended doing that or not doing that? Okay.
Hearing people. Yeah. Do that.
Oh, no, to put them up simultaneously. Yeah. So for the VX, it's not a, can we do it on the VX? I don't think we can on the VX yet. I think it got fixed on the VS and GVs and NV
They
lights.
said it's coming.
Yeah. Yeah, the goal is to have everything standard. When you're 100 years old like us, you'll have it. So for what it's worth, the GVs are shipping with the new AUI now. Mike's got one. We just, about NAB time, released the AUI for all GV customers, legacy and everything.
This is what it looks like.
Oh, the field modification.
Okay.
Thanks.
And yeah, so it's been a long, brutal, painful process. And I will be retired before it hits the last NVs, I'm betting. I might be wrong. I could be. So here's the cool thing. Total sidetrack, doesn't matter. The way that Scott and Cameron are going with it, they had to do a full pivot. They realized, especially on the VS, that little processor just does not have the headroom by about 300%. It's that overtaxed that there's no way it's ever going to run new AUI in its native form. So they looked at what Flash was doing and said, well, wait a second, Flash is downloading most of this stuff to the user's device. So you're running most of the actual math and processes on when you're running Flash, it's all happening on your device. It's not happening in the subject device, what you're monitoring. So at that point, Cameron started looking, and that's when he found, and I forget the fancy word. I was hoping you'd remember. I've got a presentation for it. Yeah. But anyway, so what it basically does, it downloads what we're doing. It downloads all the math into your device, your phone, your tablet, your computer, whatever. So the only thing that the transmitter at that point has to do is serve up the data, send the numbers. So it sends the numbers, the computer does all the math and builds the display and does all the graphics internal on the computer, which means that the first time you access the new AUI, it will load that cookie or whatever it is into your computer. And you can do it directly from the transmitter itself, or you can, if you hook up and you're online, it'll go to our servers and download it. And that part is a little bit, it's all Greek to me. Again, I grew up in IT or in RF. I don't know a lot about IT except what I've managed to blow up over the years repeatedly. Hey, man, and I were talking. So she goes, yeah, if you could just text me your credit card number, because last year we had the discussion. I said, we're not allowed to email credit card numbers. Our IT security will, number one, block the email from being sent. And if you try to send me a credit card number, I will never, ever see it. So all well and good. I'm scrolling down my texts and I say, oh, look, here's the credit card number from last year. You could have just used that. She goes, I don't keep that stuff. And it's like, oops, apparently I do. never thought to send the text and delete the text after it's sent. So anybody who could steal my phone, assuming they could get my face, would have full access to my credit card number. You could have bought a car. Nobody'd be able to prove it was you.
Too on your phone with the badge, knowing you. If you keep all those text messages, I don't even keep text messages.
I don't delete text messages just because they're a pain in the rear to delete from the Tinker Toy. On my Android, they're easy.
Easy to delete. I'll
No.
teach you later how to do it.
I know how. I just don't like it. Okay, a bunch of acronyms. We'll skip. Anybody running HD? I know y'all are. Anybody else run HD? All right, couple. So we'll hit some of the what? What's that? Oh, there you go. I mean, everybody in the beginning did high-level combining with an analog transmitter, digital conduction transmitter, and injector, and dump a pile of heat into a reject load. And I don't know if I've covered all the different combining methods. Anyway, so then now your two primary options are separate transmitters into separate antennas and space combine, which is arguably the most efficient. However, if your transmitter is in the middle of your city of license, then in the near field for the first kilometer or two, the first mile or so, I'm bilingual, I speak English and American. But for the first couple of kilometers away from the tower, unless your patterns are exactly replicated, which they never are, then you're going to hear different peaks and nulls. And if you hit an analog null at a digital peak, anybody listening on a legacy receiver is going to hear as they drive through there. So when your tower is in a field a couple of miles out of town and there's nobody in the near field of it, separate antennas is the way to go, especially if you own the tower and don't have to pay a lease on it. A lot of factors. I told somebody I don't think I've ever, except y'all have standardized a lot. ABC did a lot in the early days, but I don't think I've ever seen two FM sites exactly alike. If they're, like I say, if it's out of ways, separate antennas, if you own the tower and don't have to pay lease for the extra space, depending on what the lease is, it will tend to be less expensive. If you're in town, or if that's not an option for whatever reason, hybrid transmitter is the way to go. Transmitter guy likes hybrid transmitters because they get to sell you a bigger box. Fred? Oh, yeah.
We did. We did right there in Detroit.
You're running separate in Buffalo too, aren't you?
Well, we're not now.
Okay.
Detroit, we had two identical 4-bay ERIs, one on top of the other. That one of them top was analog, the bottom was digital. And we were right in the middle of town with the Jeffries Freeway going right through our,
Mhm.
and we had no issues.
Right. Yeah. Now you get two identical antennas, you're going to have identical pattern. Now, I mean, they're offset a little, so there'll be a very slight difference, but
Not
other than
enough
that.
reflection stuff.
But like if I've got a 16 bay and a 2 bay or a 3 bay or whatever, then those numbers, yeah. So again, you've got to look at this all very carefully. The HD will keep running. Yeah. Now, an HD receiver should,
We've had
because it's like
We've had-
digital only at that point.
issues with that happening. And where like the analog transmitter would go down, there's a problem with it. We put the HD transmitter at the plus
Hybrid mode, yeah.
hybrid mode. Keep running.
Yeah. But I mean, the digital transmitter is running digital only at that point, and our HD receiver that is geared to handle digital only, which is not a lot of them at the moment. I think there's 10% of them will handle MP11 or MP11. MP5 or 11, which one's all digital?
MP3 on AM.
MA3, yeah. Yeah.
MP3 is.
That's right.
It's not. No, MP3 is FM all digital or FM hybrid too. And but that is another thing that is a really good point. A lot of folks hear FM and MP3 and just assume that that means, well, what do you mean you only got a 64 kilohertz bit rate? 64K bit MP3 sounds like crap. It's, yeah, not the same. They should not have picked that. Of course, then again, HD radio. Are you recording? No, you're recording. Anyway,
Did anything else?
I'll go on record. HD stands for high dollars.
It really does.
But, and I mean, having said that, it's a lot less than it used to be.
TV stands for great value.
Or Grass Valley, depending. And that is a funny little side note, though. We got into this years ago. You remember the Q series FMs? You had a bunch of them around here. The original, so Mike Woods, our head of engineering, has been with us longer than I have, and I've been there 34, almost 35 years now. And Mike's a musician. And Mike wanted to, when we started in 2005, actually trying to do some marketing instead of just building transmitters and having engineers do it. Engineers are great designers, but terrible, terrible, terrible marketers as a rule. So when we started doing some marketing, Mike wanted to give the transmitters sexy names, and he's a musician. So the J1000, J was for jazz. Okay, the V series was for virtuoso. And the Q series, he wanted to call it quantum. And I said, hold the fort here a little. He goes, what's the matter? And I said, that's already been used. He goes, by who? And I by a little company called QEI, and we don't want to model any of our gear after any of their gear. So the side note for the recording, why do they paint QEIs red? So you can find them in the smoke-filled room. Okay, I'll shut up now. This is where I go, straight off the rails. So look at that. There's, okay, MP11 is the expanded digital mode. MP5 is the all digital. There you go. That answered that question. And that's why with HD, like you're adding these 24 kilobit channels, that's a really low bit rate audio signal. And they're using a modified AAC plus codec essentially. And if you've got some good perceptual coding for low bit rate audio, it can sound pretty good. Is it going to sound CD quality? Absolutely not. It's a 24 kilobit digital stream. And that's the point. It's a stream. Don't process it with an FM processor. Like don't put an Omnia, well, you can do it with an Omnia 1, but don't put like an Omnia 6 on an HD signal. Use an Omnia 1, but get the streaming package in it. Okay, or an Omnia 9, which is already coded for low bit rate audio. But if you're going to use an independent outboard processor for HD 234, use a streaming processor, not an FM processor. It'll sound so much better. Okay, because those processors are already geared for handling low bit rates. Other challenge, if you notice that we're getting into the 100 kilohertz range here. If you're cranking up the audio a little on your A or FM on your analog, not that anybody would ever exceed 75 kilohertz deviation, of course. But if you are, you will start stepping on the FM carriers, or on the HD carriers rather. Okay, by the same token, 92 kilohertz SCA, subcarrier, pretty much gone. So something else to pay attention to. These are just, like I say, things to be aware of. Don't have the one I want there. Just various infrastructure stuff. I'm not going to read the wall of text. Y'all can read, and I can make this PowerPoint available after the fact anyway. This one we run into a lot, IP conflicts. Other thing, so HD radio, prime example, between us and Gates Air and BE, I think BE and Gates Air both use the default port assignments that Xperi signed originally. We use different ports. So if you're taking a FMXI HD generator from Gates Air and putting it on an Autel transmitter, you're going to have to change port assignments. Okay, not a problem. We can walk you through how to do it. But just be aware, that's the kind of thing you got to deal with. I've got a lot of people telling me that their RDS isn't showing up on the air and it's got to be the transmitter's fault. But if you put port peaker at the transmitter end, set it to the transmitter IP and port number, there's no data coming to the transmitter. It's almost always a path problem. Almost always, not 100%. Port for RDS 7005 is what we use. So again, these are the kind of things we run into a lot. Sample rate conversions, I cannot beat that over. And this is audio 101. Don't use sample rate converters anymore, and you have to. And if you got to, down converting is okay. You can't put the bits back after you took them out. Just didn't go to happen. Oh, one other thing that I did not put here or here, but this is a good one for HD too. Peak voltages. I've run into situations where we had a guy bought a 10 kilowatt transmitter, wants to put HD on it. Had the headroom, power headroom, he only needed 7,500 watts, which is fine. He wanted to crank the HD right up. Well, a 10 kilowatt, the thing to remember, the HD carriers are amplitude modulated on the FM carriers, so you've got to look at the peak envelope power, which means that if at 10 dB injection, minus 10 dB injection, 10%, if I've got 10 kilowatts analog, that's 1 kilowatt of HD power times 4 for the peak envelope power, so now it's 14 kilowatts. And if my antenna bay is only rated for 10 kilowatts, I could get very entertaining very quickly and expensive. A little bit of both. So we had a combiner, totally burnt up a branch combiner because they had miscalculated the HD power. And it's peak voltage more than the peak power, but you've got to look at both. All right, top three, that's right there. That is my entire transmitter hardening discussion. And y'all just tell me when to shut up. I'll just keep roaming forever, you know that. But Amanda's not afraid to tell me when to shut up. But shut up. Oh, that's right. But keep it cool, keep it clean, keep it well grounded. If you do those three things, again, don't care whose logo's on the front, it's going to live a whole lot longer. Switching power supplies, primary example. One of the biggest things that kills switching power supplies is heat. Okay, they will, an example, the fans will fail if you've got any amount of back pressure. And some transmitters, the way they're designed, they have back pressure inherently, so you better force the air through them. Our original NVs were an example. A couple of the other boxes on the market. If you're not shoving the air through that switching supply, that fan's seeing back pressure. Fans have a fixed life based on static pressure and ambient temperature. And at static pressure, meaning zero back pressure, everything's just totally neutral, the air is going through on its own. A fan will nominally have a lifespan of about 5 years at 40 Celsius or 104 Fahrenheit. For every 10 degrees Celsius or 18 degrees Fahrenheit that you reduce that, you double that lifespan. So at 30 degrees Celsius or 86 Fahrenheit, you're going to be at about a 10-year lifespan. And this is nominal, it's going to vary. But if you drop it another 10 degrees Celsius or 18 Fahrenheit down to 68 room temperature, now you're at a 20-year lifespan. Okay, so in a properly air-conditioned site with the air actually going through the transmitter instead of blasting past it at 100 miles an hour, a fan can last a good long time. But once those fans on those switching supplies fail, they go into thermal shutdown almost immediately. And 99 times out of 100, when they do that, replacing the fan will not recover it. You have to, there's something that has either a little fuse or something. And it'll depend on the different supplies, what you do. But fans are probably the biggest failure rate on switching supplies, for what it's worth, not lightning surges. Lightning surges are the second biggest. And here's the thing, it's not hitting the power supply lines. It's not the dirty feed, although it could be because, you know, they put transmitter sites at the end of the field in the cow pasture, just down the road from the industrial mill that's boom, 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 boom. So, you what? Yep, with those capacitive start motors on them, on the pumps. So that could be part of it. But the bulk of it is lightning hits the tower and this giant surge of current comes down, hits Earth, which has a finite resistance per foot. Earth potential at the base of the tower spikes high. And if you don't have a surge protector to decouple that surge, it's going to look for a way to get out to dissipate. The only two options are earth resistance or, oh, look, the power company provides 1,000,000 miles of wire and ground out there, and you put this device with all these little transformers coupling us to them. Yeah. Right. So again, I would guess, and this is just a guess, I haven't looked at the math. We did do a study 1,000,000 years ago. But the vast majority of switching supply failures we saw beyond fans were the result of tower strikes, not AC power failures. I don't know how they figure that stuff out, but somebody smarter than me gets paid to do it. So keeping it cool, obviously you got to know what you got to keep cool. If you can't calculate your heat load, you got no idea. And again, this is easy math. The big thing is that's got to be AC efficiency, not DC efficiency. Every tube transmitter out there and half of the solid state manufacturers spec DC efficiency because it's a bigger number and it looks good. You need to know the overall AC to RF. Okay, if you don't have that number, you almost never do. Clamp on current meter onto each phase times the square root of 3 times the voltage, divide by the output power, you're there. Invert it, sorry. Okay, so figure out your power consumption, subtract what's going up the antenna, and what's left, how much waste heat you got. From there, you can calculate BTU per hour for cooling. You can turn that into air conditioning size in tons.
That's for the transmitter.
Yeah. Convection heat of the room, exactly. The sun is your biggest heating source in the summertime. In the wintertime to an effect or to an extent, but mostly in the summer. You need to have an HVAC technician to figure that out. I can't tell you how many times we've had somebody go through our documents, 5 tons of air conditioning. Okay, let's put in a 5-ton AC. Well, if you do that in the middle of a field in South Carolina, I can promise you that you will have a problem. Guaranteed. But we built 25% headroom into it. I don't care. The sun creates more heat than your 5-kilowatt transmitter does in your uninsulated building in July. So factor that in. Positive pressure is huge. Nobody does it. Almost nobody does it. Intake fans and exhaust fans. Intake fans bigger than the throughput of the transmitter. Exhaust fans a little less. That way, the big rule of thumb, if you got a door like this and you have to push on it hard to get it to open, the building's pushing it back at you, you've got positive pressure. Chuck Kelly used to say, you find a smoker and have him stand there with a cigarette. And if the smoke's going into the building, you got negative pressure. If it's coming out of the building, you got positive. You can do it with a match or a candle or whatever. I say he used to say, he still says that. I heard him say it not too long ago to somebody, but it's a great example. You know, so positive pressure is huge. 2 reasons. Not only does it cool the equipment better, it keeps all the dust out. Because now all the dust is all the air is being drawn in through this wall of filters, and the dust is being forced out through every crack and crevice. I was at a site in the Bahamas, one of the ZNS stations in Bahamas, Radio Bahamas. And the inside door, steel frame door, had a 1/4 inch of salt on it because it's sucking the salt air in, and it's evaporating on the door frame. What doesn't evaporate on the door frame is evaporating inside the transmitter. I have never seen aluminum rust before. Well, it was corroded. The FET cases were all solid rust. It was awesome. And it was expensive for them, not for me. I get paid either way. But yeah. So definitely, if you can do positive pressure, it's huge. It will save you a lot of grief. You know, the big challenge, what we usually do is because in the old tube days, you put a big old 3500 CFM exhaust fan up there, sucked all the air out through the tube final, get all that hot air out of there. When that exhaust fan failed, everything melted into the ground and you bought a new transmitter and started again. Or you had an actual thermal overload circuit that wasn't bypassed by somebody because that airflow thing is annoying on a BE transmitter or whatever transmitter. So I can't tell you how many airflow interlocks I've seen bypassed. It's not good. Don't do that. Don't bypass interlocks in general. But yeah, so moving the air through, but anyway, so we suck the air out. Well, we're sucking the dirt through every crack and crevice. The tube transmitter's got a high voltage supply. Dust and high voltage lead to some very entertaining arcs and flashes and stuff. So yeah, just don't do that if you can avoid it. If you can put filtered air into the building, now it costs a little more, less than air conditioning. And somebody does have to replace the filters, so there's a manpower requirement, person power. But yeah, pay attention to that stuff. And rule number 1, do not blow the air past the transmitter at 1,000,000 miles an hour. You just create a negative pressure zone, sucking air away from the transmitter and not cooling it. And that is probably my biggest gripe about transmitter cooling. The other challenge, pay attention to the transmitter manufacturer documentation. Like on our boxes, and Mike and I have been through this recently, you got intake air going in the front and the back. So you got to pay attention to that. Remember those power supplies? They all draw air in from the front. Remember what I said, the number 1 killer of switching supplies is heat. If you don't have air going in the front, it'll be a problem. So just pay attention to that. Okay. By the same token, if you've got like one of those wall mount split, mini split air conditioners like the Bard, I picked Bard as an example. They shoot the cool air out up high and it filters down, and it's great for like an office. So the air's going out up there, filtering down. Nobody gets a draft in their face. Life is good. Worst thing in the world for cooling transmitters. Transmitters want the cool air to come in down low. They shoot the hot air out at top, which is a logical physical cycle. But at that point, now your mini split's pulling the cool air away from the transmitter intake and shooting the cool air, pulling the air away from the transmitter, shooting cool air up top to mix with this and not doing anything. It's less efficient. If you can get I keep using the laser pointer, an HVAC tech to reverse that goes into and goes out of, it'll save you a whole pile of money. $1,500 of sheet metal to swap them around. Bring the cool air down so it's going into the gear, pull the hot air out, take your warm air return at ceiling height. And like it's easier. You can, a lot of them have the louvers on them that you can adjust, compensate a little bit. So that helps some. But yeah, pay attention to that. When you're building a new site, it's cool because you get to pick all this stuff within the budget. When you're inheriting a site, you get whatever the 5 people before you thought was best within the budget they had to work with. And air filters. Oh my goodness, air filters. I've walked into so many sites where you couldn't even see the ridges in the air filter for all the fluff on the back. Y'all have cottonwood here? Cottonwood season, my favorite. So I went through, did a Northeast or Upper Midwest tour a couple of years back. In Duluth, I was in somewhere in Rhinelander, Wisconsin, and I was in Saginaw, Michigan. And I took pictures at all 3 stops of different transmitters where the filters were just totally clogged. Every single one of them have been replaced within a month or so prior. They just, cottonwood season in the Midwest. You got to, your site visits, like, give an example, not to call names out, but one of my customers does scheduled maintenance. What a cool concept. Well, y'all do too. But they go to the site, and some of their remote sites, their translators, they might hit every 6 weeks, but that's their schedule. So they came to us and said, we need a different air intake that won't clog up. We need more surface area for filtering. So we're going to build them a plenum to go over the front of their VX transmitters to slow down how fast the filter clogs in cottonwood season. Just to try and hit their 6. They understand that it's still going to reduce the effectiveness, but that's the kind of thing, you pay attention to. Grounding, I've beaten this out. I mean, I've been here talking grounding before. We did that a couple of years ago in person, I think. Might have been more than a couple. It all kind of runs together after a while. But grounding is one of the things that I also see done wrong more than I see it done right. Now, having said that, I've never seen a 100% perfect, in my mind, grounded facility. And there are little things that I'll argue with people all day long and walk away from saying it's not that big a deal. But like some stuff, running your ground wire, there goes that laser still not working. Running your ground wire through a steel conduit, not a good thing. Okay, Ham's in the room besides Fred. I know Fred is. A couple of you. You ever build a choke, taking a piece of wire through a ferrite? And ferrite's a ferrous piece of material. A steel conduit is a ferrous piece of material. You run a ground wire through a steel conduit, you just made a one-turn inductor. Now, what's the inductance? I don't know. Depends how much steel, how long it is. It's going to be some variation there. Yes, and you can buy, you were the one that told me that, I think, conduit nipples that will pierce the jacket of the, or the insulation of the ground wire to make the ground wire and the conduit one. You can also get PVC conduit. There are a lot of areas where the building code requires any exposed wire to be in a conduit. So I get why they did it. This one is Gordon Carter's site at WFMT in Chicago. And I growled at them about it then too. So they did go back, and I think they put the little conduit nipples. I'm not 100% sure. But yeah, so don't do that. By the same token, this wire is about a foot longer than it needs to be. Short, straight run. Here's the thing to think about. This is the thing I tell people. When you're looking, grounding is a game of current divider, okay? Now, if I use a 2-gauge piece of wire, it's got a nominal resistance, depending on the exact composition, of about 0.16 ohms per foot, give or take. Piece of 4-inch strap has got a resistance, depending on thickness again, about 0.0016 ohms per foot, 1/100th of the resistance. When you're looking at 100,000 amps coming down a tower and hitting the base of the tower, 1/100th of the resistance doesn't look nearly as good as 100 times the, sorry, 1/100th of the resistance looks a whole lot better. So again, current divider theory. The goal is to keep the gear or the surge from going through the equipment, have it go around through the surge protector between the AC lines and ground. And if we can keep that path the lowest resistance possible, and then maybe use the 2-gauge wire from the surge box over to the transmitter to raise that resistance a little, use ferrites on the coax and on the AC lines to raise the effective impedance of them to any high frequency component. And again, ferrites on their own, in spite of my reputation for being the guy that says you got to have ferrites on everything, ferrites on their own aren't going to solve the problem. If your grounding is shit, the ferrites at the best will just do nothing, and at the worst will explode on the first good strike, which is awesome to see, preferably on a video camera, not in person. Do you know Lynn Willoughby down in San Antonio? Okay, I know he was down there when you were down in Texas, but San Antonio is a long damn way from Dallas. I know, and you don't know every contract engineer for every 900 stations. All right, I'm feeling kind of disillusioned now, you know, but he is only human. And 100 years old, we discovered earlier. But yeah, so Lynn was wiring up KDRY XL12 a bunch of years ago. He calls me and he goes, Jeff, we got a problem. And Lynn's a sharp engineer. He knows his stuff. I don't even know if he's still around. I haven't heard from him in years, but we're all getting older. If you get to talk to him again, tell him Jeff was telling stories about him. So he called and he's like, I got this transmitter. He goes, everything's grounded, but he goes, the ferrite, it's weird. I put the ferrite on the coax like you said, but it's getting warm. And I said, well, that means you got a current imbalance. The feed through the feed and the return current are not equal, so the ferrite's saturating. That's all that is. He goes, you don't understand. The transmitter's off. We're on the other transmitter. I said, oh, well, then you have a big current imbalance. So he turned the other transmitter off, turned the XL12 on, and the ferrite exploded. I got to hear it over the phone, not the ferrite. I got to hear Lynn over the phone when the ferrite exploded. But yeah, I mean, a ferrite basically is a ferrous ring. It's carbon iron filings or some other ferrous material and epoxy to hold it in shape. And if you have a feed and a return current that are equal, it does nothing. It's inert. It just sits there. But if you get an imbalance in those currents, then the ferrite will saturate, the H field will generate an equal and opposing current in the opposing conductor, so the potential difference between the two is balanced a little better. Not exactly the same, but it's going to be a lot closer than if one spiked and the other one stayed at ground or whatever. So they help balance it out a little like that. For any high frequency component in the lightning strike, and Polyphaser did a study that showed that any tuned circuit, when hit with enough current, will oscillate at the frequency it's tuned to some extent. So, you know, again, they'll help add some impedance to that, so you don't have that blowing stuff up. So they help, but you got to have good grounding. You got to have good surge protection. Those are the key things. If you've got those, you might not even need the ferrite. At that point, they're just built to the braces.
We have ferrites on shielded Cat5 wire from the tower.
Mhm. Yep.
You can put your hand on them,
Right.
but they're
And that means you probably got a lot of AM on that shield wire. So it's just induced AM. Yep.
better to stop it there right where, and that's right before it ties
Right.
to the ground.
And I mean, ferrite on Cat 5 to an ODU is huge, because I've seen ODUs blown totally off of towers with the coax total, or the Cat 5 totally burnt till it gets to the ferrite. I mean, it'll burn a little past that because physics is physics,
Yeah.
but you're not blowing up whatever it's connected to at the bottom end, and that's, you know, usually considered to be a good thing. There's the other one I wanted to hit. Oh my goodness, people need to focus on getting standard audio levels throughout their facility. And I don't care what your standard is, pick a number and that's your reference level. Whether it's 10 dBm, whether it's minus 3.5 dBFS in a digital AES, I do not care. But set a standard from the mic processor to the input of the exciter, and it'll make your life so much easier when you're trying to figure out why this signal's not as. So engineer who is one of the top engineers in our industry, probably does more teaching than I do, brilliant guy, called me up and he says, can't get my HD2 as loud as my HD1 isn't as loud as my analog. You remember back in the AM days, we used to have to play, there were like 8 different controls we had to play with to get that to work. Well, this was on an FM, a lot simpler. So we went in well, he had 25 dBm coming out of here, switching to digital, minus 4 dBFs or Fs, going through an up converter, going this. Every piece of equipment in the audio chain had a different reference level. So we went through and we picked a level. I don't remember what level, it doesn't matter. But we picked a level and standardized all the way through. Got to the other end, and the two were within 5% modulation, just without making a single adjustment to the actual. We just started setting a reference level. It's amazing how much, and at that point it was an easy. At the very last end, we adjust the output of the final processor for the HD signal, bang, everything just all fell into place. Because I never would have thought of that. The problem is Orban standardizes on 3 dBFS for digital signals. Omnia standardizes on minus 4. That's what we use. Other people use minus 3. And that's their standard for 100% mod. So it's all different. And if you tweak any one thing, you could run this into clipping and that into saturation all in the same time. So have a reference level and run it through the whole set. And again, that works well for ham radio site too. You know, and I've seen your ham shack. Have you got it rebuilt yet? I'm easily amused. So, and I'm sure everybody here has heard the story of Fred burning down the ham shack, so I won't repeat it. But I do get some very, very pleasure. Time alignment. 99% of the time alignment we run into issues are because the audio is not properly clocked. It's got very little to do. Now, if you get a path with a lot of jitter, crap's going to happen. You can't stop it. Physics is physics after all. But if you have everything at the transmitter site, your audio is properly clocked, it's going to be locked in, period. You know, with the new software-derived HD system, we've eliminated the problem because you do the separation and the rejoin all in the one box. There is no time alignment issue. Turns out that the delay also drops to about 5 seconds, which is kind of cool, but an absolutely useless feature because you still can't listen live to a 5-second delay. So, you know, whatever, whether it's 10 seconds or 5 seconds is irrelevant. But yeah, so time alignment, that's one of the big things, having the audio clocked. What I tell folks is you put your processor and your HD generator in the same place, take the sample out of the HD generator and run it into the 44.1 word clock on the processor, and then actually turn the clocking on in the processor. And that'll make a difference. It'll make a huge difference. Oh, look, yeah. Don't bypass interlocks. If you have to bypass an interlock, put it back. Please, please, please put it back. I can't tell you, SX series with the paper clip. They're not the paper clip. They had the piece of, because those had the big interlocks that you had to, they were normally open. And you had to jam a piece of cardboard in them to bypass them. Not that I would know anything about bypassing interlock. Ground stick, AM stations especially. You ever work on an AM, turn transmitter off? Maybe even ground it at the output of the transmitter if it's one of our XLs or NAs. Go to the tower and discover that there's still a lot of voltage out there because, shoot, just a windy day will create static. But if there's another transmitter within 5 miles, your antenna is going to receive as well as it transmits. So ground the base of the tower, always. And phone number list. We've kind of gotten off that these days because everybody has all the phone numbers in the phone, but what happens when your battery dies? Of course, and again, who has a landline out at the transmitter site anymore?
We have IP phones.
Look at you being all fancy. But yeah, you know, I mean, having the phone number list is still useful in my mind. All right, there you go. I'm done rambling. I ran out of
Stop.
Thank you. One thing, we have started doing more not user videos, how-to videos. Support has done a bunch for the VX now on how do I do this or how do I do that. Those all go on the YouTube channel. Under resources and webinars, that'll be me blathering on about stuff like this. So, or whoever would happen to be putting on whatever webinar, but somehow I get suckered into most of them, it seems. Probably because I'm not afraid to stand up here and talk about stuff I know very little about. I think I've learned a few things over the years. Hey, questions, comments, thoughts, criticisms, concerns. Anything to do with the industry. As you've discovered, I'm not shy. That's a loaded question that I will not answer on a recorded session. I will tell you that, I mean, you've got different markets. You know, Gates Air's got the FMXI does have built-in time alignment. A lot of customers like that. So a lot of folks are buying those. I think Rode still sells some liquid-cooled FM here and there. I'm not sure. Again, I don't have access to their what they do. Low power, everybody and their dog's building a low power transmitter these days. VX, we've got probably close to 1,500, 2,000 of them in the field in the past 3 years. So they're still going out. You know, we ship several a day. But, you know, BW Broadcast is back in business through Progressive Concepts in Chicago. Elenos is now spun off and separate and owned by DARPA, I forget the company name, I'm sorry, in Italy. BE is independent, but still owned by Leonardo out of Italy. They're still doing the STX, and then they've got that, I don't know what their other models are. They've got one that looks like a rebadged Italian transmitter, but it's all good. AAT is still going out of Sacramento. They've got some decent product. Obviously, you know, I'm biased. AM, it's us and BE up to 10 kilowatts and us above 10 kilowatts for North America. Gates Air has been out of AM. They will quote you an AM at list price, according to, I asked Paul Berzies about this recently, so I don't mind repeating it. But he said he will quote you a transmitter at list price. If you really want it, they'll build it. But yeah, and they will not do HD for AM at all. Will that change? May, who knows? Again, that's their business. I don't try to judge their business or figure out, you know. No, world market for AM is significant. Not really. There's, I mean, 25 kilowatts and up. There are still a few 5, 10 kilowatt lower power AMs, especially in like African villages and small communities. There's still a fair pile of it. But when you get into the areas where AM tends to be most prevalent, the ground conductivity tends to be not nearly as good. So you need more watts to cover the same distance. You know, it's like my running joke is we've been turning sand into glass all over the Middle East for 50 years now, or give or take. But yeah, there's still a really significant AM market overseas. Obviously not in Europe. They're turning off FM, conventional FM in a lot of countries in Europe now and going with DAB. DAB won't work here in spite of what all the cheerleaders say, because our geography is such you don't have the physical coverage. Think cell sites. A DAB transmitter typically is L-band, 1.5 gigahertz. Getting past the fact that the US military didn't want to let go of the spectrum, which they're not using, but that's a different discussion. In Toronto, they needed 6 pods to cover what one class CFM on the CN tower would cover at 10 kilowatts. And that's a Canadian class C, by the way, not like a 100 kilowatt C3. But 6 pods to cover the same, and they weren't getting as much coverage on the edges. So now you need 6 transmitter sites instead of 1. Now, granted, you can put on a DAB pod, you can put as many as 6 stations in it. So each transmitter will hold 6 stations. Can you imagine? Now, 5 years ago, you know, or 25 years ago, I would have been like, can you imagine having this big group station and this public radio station and this little independent station all on one pod, all agreeing to work together and buy the same transmitter communally? Wouldn't have worked at all. Too much socialism involved there. But yeah, anyway, it can happen. The challenge becomes you get into a really rural area. You get into Dickinson, North Dakota. 2 radio stations in that town. You're going to put up 6 transmitter sites for 2 radio stations and one owner carrying the entire cost of all of that? It's not physically or fiscally possible. DRM Plus works on the conventional band. Sure, absolutely. Why not? HD radio does the same thing. It's one transmitter with, multiplex with 6 signals. Yeah. Because remember, at 1.5 gigahertz, 6 signals are, it's not like putting 88 and 108 into one FM transmitter. It'd be more like putting 96.1 and 96.3 into one transmitter, which we've already proven we can do. So, yeah. So worldwide, and I mean, ultimately, doesn't matter what we do here, everything we do here and all the discussions we do here don't mean squat if they're not putting a signal on the air people want to listen to. It all comes down to the product, 100%.
Content is key.
Yeah, I mean, I'm one of them people, I tend to run because I don't scan the radio on the road. Number one, most cars these days, it's too hard to find the radio. Whereas I get in my phone, the real phone, not the iPhone, and start Android Auto up, and it automatically loads YouTube Premium and starts playing my music library. And I mean, I listened to everything from AC/DC to Torrin Wells coming in last night. You know, there you go. Now, having said that, I do like Caleb's Air One formula.
They're older.
Okay, well, it's changed.
I
You're
know it's
fair.
changed. I
That's fair.
like it.
But again, it comes down to the content. If, you know, if you're not putting something on people want to hear, they aren't going to listen. It doesn't matter how much we put lipstick on the pig. So that's my big gripe. We got to work together with programming. And how do we do that? I do not know the answer. I mean, a whole lot of people smarter than me and said, this is what people want. I'm here to tell you that my wife is my prime, because she knows nothing about this industry. She's a pure consumer. We'll get in the car. I got the radio on. First commercial, she hits seek. You know, if there's 2 commercials in a row, that station's gone. If it goes off the air, 3 seconds is the off-air limit. 1 second to realize it's off, 1 second to realize it's not coming back, and 1 second to reach for seek. Once she hits seek, she's on that station until their first commercial. So, or until the DJ starts talking at her instead of to her, which is the other big thing. So it's, well, the host, whether it's voice tracked, whether it's live, it doesn't matter. So, you know, now my station, we tend to, we do it a little different. We have a pretty full commercial set because Canadian commercial or community station can sell headspace. But we play a commercial, we play a song. We play a liner, we play a song. We play a spot, we play a song. We play, or give the weather, we play a song. You know, you'll never get 40 minutes of nonstop music, but you won't get 5 minutes of nonstop commercials either. So, you know. Yeah. It's the power button. Little US, what is it?
Just showing that it's on the back.
Power indicator, excuse
There you
me.
go. Mr. RF.
Green lady, hey. Any other questions or thoughts, comments?
We can talk later.
Yeah. Oh, we will.
But these folks
Folks, thank you all very much.